In this section, we will review basic exponential properties. And although there are 5 to 8 exponential properties, depending on how you count them, all of these can be traced back to the basic definition involving repeated multiplication for an exponential term. So let's consider the term 4 cubed. So our base is 4, and our exponent is 3. And the exponent indicates how many times the base occurs as a factor. So in this case, 4 is going to occur as a factor 3 times, which gives us 4 times 4 times 4. And this is going to be the basis of our laws of exponents, this definition involving repeated multiplication for an exponential term. So let's take a look at our first property here, which is the product property of exponents, sometimes called the product rule. And let's consider starting with 4 cubed times 4 squared. All right, now we know that 4 cubed means 4 times 4 times 4. And we're multiplying that to 4 squared, which means 4 times 4. And so we see here we have 5 factors of 4. So essentially this is equivalent to 4 to the 5th power. Now, the product rule says instead of expanding our problem in this way, instead we can just, if we're multiplying, we can add our exponents. So we would have done 4 to the power of 3 plus 2, and that gives us 4 to the 5th. And as you can see, we would have arrived at our simplified expression in a much quicker fashion. Okay, secondly, we have our quotient rule for our law of exponents. So let's consider the example 4 to the 5th divided by 4 cubed. So if we expand that, that is in our numerator, we have 4 times 4 times 4 times 4 times 4 divided by denominator 4 times 4 times 4. And if we simplify that, we're reducing 3 pairs of factors. So we're left with 4 times 4, which equals 4 squared. Now, if we use our quotient rule, the quotient rule says when you're dividing, you can subtract your exponent. So instead, we could have done 4 to the power of 5 minus 3, which gives us 4 squared. And again, we arrive at our simplified expression more quickly. All right, thirdly, we have here our power rule. So let's consider the example where we have in parentheses 4 squared, close parentheses cubed. So we're cubing 4 squared, which means if we expand that, that is 4 squared times 4 squared times 4 squared. Right, and if we want to use the product rule here, we know we can add our exponents 4 to the power of 2 plus 2 plus 2, which gives us 4 to the 6th power. All right, now if we use the power rule, which says when you have a power to a power, you could multiply the exponents. So instead, we could have just done 4 to the power of 2 times 3, which equals 4 to the 6th power. And again, we arrive at our simplified expression much quicker. All right, so now we're gonna delve deeper into our negative exponent law and our zero exponent law. So we're going to see some examples and then we'll revisit this table at the end. So let's start with the definition of b to the 0 power, assuming our base is not equal to 0. So let's consider 3 to the 0 power. This particular definition says that it's equal to 1. I like a different color. Let's get my blue. Here we go. All right. So that might be a bit unbelievable to you. So let's consider a rough proof, right? Starting with 3 divided by 3. That's equal to 1. Okay, wonderful. So let's consider 3 squared divided by 3 squared. Okay, that equals 3 times 3 over 3 times 3, which if you want to look at it as 9 over 9, you can, but that's equal to 1. All right, so let's consider the 3 squared over 3 squared again. But this time, instead of expanding, I'm going to subtract the exponents because this is a quotient. So 3 to the power of 2 minus 2, which means that equals 3 to the 0. Well, we already saw from above that 3 squared over 3 squared equals 1. So 3 to the 0 must also equal 1. All right, so that's a bit of a rough proof. Let's look at this in one more example. Let's consider 3 cubed over 3 cubed, right? So again, that's 3 times 3 times 3 over 3 times 3 times 3, which gives us 27 over 27, which again is 1. Now, if we take 3 cubed divided by 3 cubed again, this time, instead of expanding, we'll just use the quotient rule, which says subtract the exponents. 3 to the power of 3 minus 3, which equals 3 to the 0 power. And we know that 3 to the 0 power should equal 27 over 27, everything that we had right above. So 3 to the 0 again should equal 1. Right? So hence, a non-zero number raised to the 0 power, we know will equal 1. So that's just a bit of a rough proof. So now let's use what we know about that. We'll try some examples here. All right, so starting with 4 to the 0 power. Easy peasy. That equals 1. All right, let's take a look at letter B. In parentheses, we have -4, close parentheses, to the 0 power. Everything in parentheses is raised to the 0 power. So then that equals 1. All right, now C is a little different because we have a negative and then 4 to the 0 power, which equals, that negative is an implied -1 being multiplied to 4 to the 0 power. All right, so that 1 is an implied 1. You have to remember that. And now your order of operations says evaluate your exponents first. So then we get -1 times 4 to the 0 is 1. And then do the multiplication. So that's the -1 times 1, which is -1. We didn't worry about that in part B because the -1 and the 4 was in parentheses. So each of those was being raised to the 0 power. All right, letter D. Z to the 0 power equals 1. Okay, now you might be wondering, what about -z to the 0 power? Well, that would have been like letter C. It would have been -1 times z to the 0 power, which equals z to the 0 power is 1. So that's -1 times 1, which essentially gives us -1. So the moral of the story here is that negative is not inside of parentheses with the z, then the exponent only goes to the z, not to the negative. All right, so take a look at letter E. Similar situation, the exponent of 0 is for the z, but it's not for the 4 and it's not for the negative. And so this equals -4 times 1, and that equals -4 as your answer. All right, letter F. The 4 and the z are in parentheses, and then outside parentheses, you have your 0. So that means everything in parentheses is taken to the 0 power. So then this is equal to 1. Okay, now we have our 2 examples off to the side here. We have the 3 parentheses, -5/3, close parentheses to the 0 power. Okay, so everything in parentheses is being taken to the 0 power. So the -5/3, all of that to the 0 power equals 1. So we have 3 times 1, and then that equals 3. All right, our second example here, we have negative parentheses, 2/3, close parentheses to the 0 power. Now that negative has an assumed 1 with it. So it's like saying -1 parentheses, so -1 times what's in parentheses, outside of parentheses to a power. So let's take our power first. 2/3 to the 0 power is 1. So we have -1 times the 1. So our answer is -1. All right, our next definition here is regarding negative exponents. All right, so it's saying here that a non-zero base raised to a negative exponent is equal to a reciprocal. All right, so we have 3 to the -2 is going to be equal to 1 over 3. And then when you take the reciprocal, the exponent becomes positive, so squared. 1 over 3 squared, which we can evaluate to be 1/9 now. Conversely, 1 over 5 to the -2. When I reciprocate the 5 to the -2 in the denominator, that's going to equal 5 squared, which I can simplify to be 25. Okay, so let's just take a look at a rough proof of why this is the case. Okay, so let's consider the number 3/27. Okay, if I divide 3 over 27 by a factor of 3 over 3, that's going to give me 1/9. All right, now let's remember that. So I'm going to start again, okay? So if I have 3 over 27, we already know that's equal to 1/9. All right, now if I think about this in terms of exponential expressions, 3 can be written as 3 to the first power. 27 is equivalent to 3 cubed. Okay, and let's consider that if we have 3 to the first power over 3 cubed, if we use our quotient rule, we can subtract our exponents. 3 to the power of 1 minus 3, which gives us 3 to the negative 2. Well, we already know that 3 over 27 equals 1/9, right? So if 1 over 9, that's equal to 1 over 3 squared, which has to also equal 3 to the negative 2. All of these have to be equivalent. Okay, so keep that in mind. Just a rough proof of why that works. All right, so let's apply some of these. We have 2 to the negative 3. Based on our rule, if I take the reciprocal of my base here, my exponent becomes positive. So I have 1 over 2 cubed. I can simplify that. Remember, that's 1 over 2 times 2 times 2, which is 1/8. All right, letter B, we have 1 over 6 to the negative 2. So when we take the reciprocal, that's equal to 6 squared, which again, it's 6 times 6, which equals 36. All right, letter C, we have in parentheses -8, close parentheses to the negative 1. So when we take the reciprocal, we have 1 over, in parentheses, -8. We can put to the first power, but it's not necessary. It's also not necessary to write the parentheses now. It's in the denominator and the exponent is a positive 1. So this is equal to -1/8. Notice how I put my negative out front instead of in the denominator. Those are equivalent answers. All right, letter D, we have 1 over parentheses, -8, close parentheses, to the power of -2. So when we take the reciprocal, this equals parentheses, -8, close parentheses, and the exponent goes from negative to positive. Notice how the exponent changes sign, but the -8 does not. All right, so now this is equal to -8 times -8, which is positive 64. All right, let's try evaluating this expression here. 5 to the -1 plus parentheses, -2, close parentheses, to the -3. Go ahead and pause the video. Try that on your own, then we can do it together. Okay, so first, you can see 5 to the -1. That is equivalent to 1/5. Plus, and then the second exponential expression, the -2 in parentheses to the -3, that's 1 over parentheses -2 and cubed. So essentially what we get here is 1 fifth plus negative 1/8. Okay, so if you want to find a common denominator between the 5 and the 8, then looks like our 40 is going to be our least common denominator. So if I take 1/5 and I multiply that by 8/8, right? And if I take the negative 1/8 and multiply that by 5/5, all right, that's going to give me 8/40 plus negative 5/40. And we end up with 8 minus 5 is 3/40. All right, if you got that, well done. So now let's take a look at the examples on the bottom. We have in parentheses 1/6, close parentheses, to the power of -2. So remember, you're taking the reciprocal of the base. In this case, our base is a fraction, so we would get 6/1, and now our exponent goes from negative to positive, right? Now, you don't need to write 6/1, right? 6/1 is just 6. And so our answer here now is 36. Okay, try letter B. Pause the video, try it, and then we'll do it together. All right, so I think you would have started with taking the reciprocal of -3/5. The reciprocal of -3/5 is -5/3. All right, now when we take the reciprocal, our exponent is going to go from negative to positive. Okay, now that our exponent is positive, let's expand this. So we have -5/3 times -5/3 times -5/3. All right, and so when we multiply this, a negative times negative times a negative is a negative. 5 times 5 times 5 is 125. And 3 times 3 times 3 is 27. All right, here we have another expression. We have parentheses 5/3, close parentheses, to the -1 power plus 5 to the -2 plus parentheses -2, close parentheses, to the 4th power. Pause the video and try this, and then we'll do it together. Right. I hope you were careful with this expression. It's easy to see all negative exponents. All right, so it's not all negative. So we start with the first 5/3 to the power of -1. I'm going to take the reciprocal, and that gives me 3/5. I don't need to put this in parentheses and raise it to a power of 1 because now that's implied. Next, plus 5 to the -2 is 1/5 squared. All right, and then plus, and then the -2 in parentheses to the 4th power, we don't need to take a reciprocal of because the exponent is positive. Okay, let's just simplify this a little further by evaluating our exponent. So we have 3/5 plus 1/25, and then plus And we have a -2 in parentheses to the 4. So that's 2, 4, 8, 16. All right, now we want to simplify this further. We need a common denominator. So 3/5, we're going to multiply that by 5/5 so we can get a denominator of 25. So that's going to give us 15/25 plus 1/25 plus 16. Okay, 15/25 plus 1/25 gives us 16/25. And we have the plus 16, which basically means we have 16 and 16/25 as a mixed number. Okay. All right, let's take a look at these 5. So if you can do these 5, you got it. So go ahead and pause the video and try these 5, and then we'll do it together. Okay, starting with letter A, we have parentheses, 5x, close parentheses to the -3. All right, so take the reciprocal, we have 1 parentheses, 5x, close parentheses to the power of 3. You don't need to go further for this right now. We're just focusing on writing the expression without the negative exponent. We'll simplify this further later on. All right, letter B. We have parentheses, -5x, close parentheses to the -3. This is similar to part A. So this is equal to 1 over, and then in parentheses, -5x, close parentheses, and then your exponent goes from negative to positive, so to the power of 3. Again, don't worry about simplifying this further for now. We'll do some more of these in a couple lessons. Okay, letter C, 5x to the -3. Notice there's no parentheses around the 5 and the x. So that means that exponent of -3 is only for the x. In essence, you could think of this as 5 times x to the -3. So it's like you're saying 5 times, and then you take the reciprocal of x to the -3. That's 1 over x cubed. Or simply put, that's 5 over x cubed. So if you went straight to the answer for here, that's fine. I'm going to do that for letter D. All right, letter D, we have -5x to the -3, which again means -5 times x to the -3. So when you take the reciprocal, you're only taking the reciprocal of x to the -3. So we have -5 over x cubed. And letter E, you have 1 over 5x to the -3, which again is equal to 1 over 5 times x to the -3. So when you're taking the reciprocal, it's only for x to the -3. So it's x cubed over 5. Okay, so let's go back to the table that we started with and fill in those last 2 laws of exponents. So we have our negative exponent. So we can remember here, we have 4 to the -2. That's equivalent to saying 1 over 4 squared. Analogously, let's say we have 1 over 4 to the -6. That is equivalent to doing to 4 to the 6th power. All right. And then lastly, our zero exponent law. Let's say we have 4 to the 0 power. That is equal to 1. And worth noting, let's say we have negative 4 to the 0 power. That is equal to negative 1. Okay, and I'll do one more iteration for this. If we have in parentheses negative 4, close parentheses to the 0 power, that is equal to 1. So notice when parentheses are used, when they're not used, how the exponent will be attributed. Okay, hopefully that was helpful.